Hello and welcome to this lecture. We're going to continue to build upon the topics of generics and get you prepared for your next assignment that is going to be very generics heavy. So make sure you're following along, make sure you're typing out all the code as I present it to you. You should actually be doing that for all of my lessons so far. But anyway, we're going to start off by defining an instance of the object class. And we're going to call it myObject. This is the variable. The type is object. Now, the object is the grandparent or the granddaddy of all objects in Java. Okay, any class you create or any class hierarchy, let's say you have the animal class and then you have its children such as bird and cat. That's a class hierarchy. The granddaddy of all objects is going to be this object class. On the next line down here, if I create a string variable, we'll call it myvar is equal to the word hello. This string is an object, okay? So what I could do is I could do myObject and give it the value of myvar, right? This is perfectly legal Java code. Because every class in Java is a child of the object class, instances we can assign them like this. And this is, of course, called polymorphism. You should remember this from the object-oriented chapters. If I define a class, let's just go to new and create a class. We'll call it employee. And let me define one more class, and we'll call it accountant. All right, so the accountant is a child of the employee class. So we can do extends employee. And so if I define an employee here, let's just call him emp is equal to new employee, and I define an accountant, we'll call it acc is equal to new accountant. I could assign ACC to emp because an accountant is an employee. And this is what's meant by polymorphism. But we can't think of it the same way when we're dealing with generic classes. Let me show you an example. Let's create an array list, and it's going to be of type employee. And we'll just call this employees is equal to new array list employee. And of course, the second set of diamond brackets with the employee inside, you don't need the employee inside since we define it out here if you're using Java 7. If you're using anything before Java 7, you need to specify it in both sets of angle brackets. So let's do the Control-Shift-O to bring in the import for array list. And I'll define another array list, this time for accountant. And we'll call it accountants is equal to new array list of accountants. So accountants are employees, but when we're dealing with generics, we cannot assign employees with accountants. Okay, this is not allowed. Even though up here, we are assigning an instance of accountant to an instance of employee because the employee is a parent class of accountant, but that doesn't mean that an array list of employee is the parent class of an array list of accountant. It doesn't work the same way when we're dealing with generics. This is a generic class, and that relationship breaks apart when we're using generics. If I hover my mouse over this error, it's going to say type mismatch, cannot convert from array list of accountant to array list employee. Okay, so you have to think of this thing as one type, array list of accountant and array list of employee. It's a separate type. List of accountants are not list of employees. So there's an important point that I want you to keep in mind. Even if I change this employee to object, right? We know that the object is the granddaddy of all objects, right? No difference. It's not going to work. So you might be thinking, generics is supposed to allow for flexibility and type safety, and this is not very flexible, right? Well, generics do promise type safety, and that's one of the reasons why it's not letting us do this, but they do offer limited flexibility. And what do I mean by limited is I can define an array list of a question mark, all right? And this is referred to as a wildcard. And we'll call it employees2 is equal to new array list. Okay? We can choose to have the question mark in here, or we can choose not to. It doesn't matter as long as we define it in the first one, okay? So here we have a list of an unknown type. This is referred to as a wildcard. So now, let's copy this code and paste it down here, and it's going to be called accountants2. Now if I try to assign accountants 2 to employees 2, it won't give me a problem. Okay? This is perfectly legal Java code. So notice the difference between these two. Over here, we're giving a wildcard. It says it doesn't matter what the data type is. It could be anything. And so since this is anything, any data type, it allows us to assign it to employees 2. Right? I could change this to be string, right? And it'll still, there wouldn't be any problems. So this actually brings us back to, we're almost using this as a raw type because it's going to consider that accountants 2 is a list of objects. That's what this employees 2 is going to consider when this data is being assigned to it. Because if we try to loop over employees 2 and get the data out, it wouldn't know what is assigned to it. It's just going to treat them as objects. So it sort of brings us back to the raw type scenario. But it's useful to know that this wildcard option exists. But where things start to get interesting even more is we can have an array list and have a wildcard extends employee. We'll call it employees 3 is equal to new array list. And there's just too much code to type. I'm going to leave the diamond empty in this example. So this basically means that this is a list that accepts data of type employee as well as children of employee. Okay, that's what this means. This question mark is going to take place of the child class. Whatever children employee class has, those children are allowed in this list. So in this example, let me copy and paste it down here. If I change this to accountants 3 and then assign employees 3 with accountants 3, it's going to work. If we change the data type, of course, I changed the data type to string up there to show an example. So we know that string is not a child class of employee. So that's what this syntax represents. So only children of the employee class could go into this employees 3 list. So let's change this to accountant because we know accountant is a subtype of employee. And now it's working as expected. So this is known as an upper bound. In other words, we're saying that the highest type, right, in the hierarchy of objects, the highest type is employee that can go into this list. So that's an upper bound. And all children of employee, doesn't matter how low in the hierarchy they are, we could have accountant, and then we can have other subclasses of accountant, like cost accountant or financial accountant. Those could be subclasses of the accountant class. The entire hierarchy all the way down to the lowest type is allowed in this employees 3 list because of this syntax, okay? And if employee was an interface, let me change this. Where's employee? Let's change this to public interface, okay? And over here, we'd have to change this instead of extends to implement. And you should remember this from the object-oriented sections. Everything else should still work fine, except for we can't instantiate an instance of an interface. We'd have to refer to the type. So let me just comment out this for now, just to show this example. Notice that everything in here is still legal Java code. So this extends keyword is just sort of a general thing that says that all derivatives of the employee class, whether or an employee interface, are allowed in here. Okay, so all derivatives of whatever this thing is, the child types of whatever this thing is, are allowed in the employees 3 list. Okay, so keep this syntax in mind. This is very important to know, and this allows for some flexibility when using generics. So this over here, this is the most flexible generics can get, but the problem is that you're going to be still dealing with the object class when you take out data from employees 2. Since it's a list of unknown type, it's going to be treated as an object. So this is sort of like the raw type scenario. But over here, we have some structure and some restriction to the kind of data that can go in here, and we still ensure type safety to a certain degree. All right, so let me go back to the accountant and change this back to extends, and back to the employee interface. We're going to change this back to a class so that we don't run into issues later, and I'm going to uncomment out this, and it should all be fine now. Okay, and this of course is not going to compile, so let me comment that out so that when I run this program, we don't run into any compilation errors. So right now this program doesn't really do anything. It's just, these are all compile time checks that I wanted to go over. If I change this to an object type, what do you think is going to happen? It's of course not allowed, because an object is not a subclass of employee. An object is the parent of an employee. So this is the upper bound. We can't have anything greater than this employee object going into it, into this employees list. That's why this thing is erroring out. Okay, so we can have employees like so. This is allowed, as well as accountants. Those are also allowed into this employees 3 list. So this is an upper bound, and it's inclusive of the employee type. So let's go over one more scenario, array list, and this is going to be called super employee, and we'll call it employees 4 is equal to new array list. And I'm not going to type out that extra code in the diamond brackets. So what do you think this means? Well, this basically means that the data that is going to go into these employees better be either an employee or a parent of employee. Okay, so this prevents subclasses from making it into the list. So let's borrow the code here. I'm going to copy it, paste it, and let's change this back to an accountant. And I'm going to change this to an accountant, and we'll call this accountants 4. This I will not be able to assign to employees 4. All right, this is not allowed. Let me put the capital letter there for accountant. This is not allowed because this is a lower bound setting. This is saying that the lowest element that can go in here, the lowest type that can go in here is employee. So I'm going to put some comments here. This is a lower bound, and over here this is an upper bound. Okay, so only employees or their parents can make it into this class. And of course we don't have a parent of employee except for object. So if we change this to an object, this code will compile fine, as you can see right here. Okay, so how would this work if we go into methods? Let me add some code in accountant class, and let's just define a method. We'll say public void work, employees work. So we'll just say, since this is an accountant, we'll say accountant working. And I'm just going to copy this code and also put it in the employee class. And instead of accountant, it'll just say employee working. Okay, so this is the parent, and the child is the accountant. Let me just add an overrides annotation, because this method is going to be overriding the default method in the employee class, because this accountant is a subclass of employee. All right, this should all sort of be a review for you from the object-oriented chapters. All right, so let's go back into this application class, and I'm going to define a method outside of the main method. I'm going to define a method called make employees work. So we'll say public static void, we'll just call it make employee work, and we're going to be invoking the employees work method in the body of this method. And the argument here is going to be list employee for this example, and we'll call it employees. And let's do the Control-Shift-O to bring in the import for java.util list. And for every employee in the list that is passed into this method, we're going to be looping over those employees and calling their work method. So there's just going to be a for loop employee, and we'll just call it emp employees, and then we'll say emp.work. All right. So up here in the main method, if I invoke this method, make employee work, and I pass in one of the lists that we've defined up here, it better be an employees list. So let's go up and pick an employees list. So let's change this back to an employee. And let's take this list and pass it into the argument of this method. And we of course need to also add, actual real employees into this list. So let me do that. We'll do employees.add new employee. All right, just one example. It doesn't really matter. Now let's hit play and notice that it says employee working. So a quick pop quiz. I want to make sure that you were paying attention. Could I call this method for the accountant? Can I pass in an accountant into make employee work? Let's go back up here and let's give the accountants list dot add, and I can say new accountant. Could I pass in accountants to this make employee work? Hopefully you got that right. I'm going to paste it here and you'll see that we have a problem. Hover your mouse and it's saying that we have a list of employee. That's the type that this method accepts, but we're passing in an array list of accountant, and that's not acceptable. All right, and this is the same exact scenario. This is the same exact scenario that we went over in this first example when we were trying to, let me uncomment this, when we were trying to assign accountants to employees. All right, a list of employees is not the parent of a list of accountants, not the same thing. So if I change this method definition down here to question mark extends employee, now it's going to work fine. Let's hit play and notice it says accountant working, because employees as well as their children are now allowed to be passed in as an argument to this method. Now the funny thing is, if I go to the and notice it's calling the accountant's work method, right? It's not calling the employee's work method, it's calling the accountant work method, because in the accountant class we are overriding the default work method in its parent, which was employee. But if I go to the employee class and I get rid of this method, let me just comment it out for now. Over in the accountant class, we need to remove the comment for override. And now this is compiling. We're going to have a problem. In the application class, when we're invoking make employee work, we're passing in accountants. And we are calling the work method for employee, right? That's the data type that's used here. But guess what? Employee doesn't have the work method anymore. Let's go to the employee class. We commented that out. So we don't even have an option to invoke the work method anymore here, okay? As you can see, the method list work is no longer there. And this is just general object-oriented programming that we've covered in the previous course, but I wanted to quickly review this for you, that the data type, that's what the method invocation goes by. Even though we're passing in accountants, the employee is the data type for what's being passed here. And we only have access to the methods that are defined in the employee class, not the accountant class. And if I change this to accountant, it's not going to work. All right, because what was this? This was an upper bound, meaning only children of employee or employee could be passed in this list, but it doesn't know which children, right? That's the important piece to this. It doesn't know which children, because this is a wildcard. It could be any child of employee. We could have a very long class hierarchy, all children of employee, and we could be passing in here, and they can have different methods, but we're not going to have access to those methods because all we can see is the employee, and that's why we have to leave the employee as the data type here for iterating over the list. So there are limitations to generics, as you can see, but it goes a long way with ensuring type safety, and it does offer flexibility, but it's certainly restricted flexibility, and you should thank the Java community for that, because you don't want too much flexibility. Java's meant to be as type safe as possible, and type safety issues should come up during compile time, as you can see right here. Now let's say I wanted to be able to invoke the work method in the accountant class, because we've commented out the work method in employee, so we can't access it using this variable. What would we have to do in this loop so that we can invoke work for these accountants? Well, you might think, oh, let me just change this to accountant, and of course that's not allowed, because the reason is, even though accountant is a child for employee, but that's really not what's being passed into this method. This question mark represents any child of the employee class, and we don't know what child it is. I mean, we know as a programmer, we know that, yeah, we're passing in accountants, but since the compiler is involved, the compiler ensures type safety as much as it can. And so since it's not sure what type we're passing, it's not smart enough to see that this accountants is a list of, the data accountant, it's going to prevent us from assigning this to be the data type. This question mark extends means all children of employee are allowed in this list. But when we specifically say that we want to access the accountant data type here, it's going to restrict us, right? Type mismatch, cannot convert from element type, extends employee to accountant. It's just not smart enough to figure that out. So what we need to do is we need to downcast this. And you've seen this in the course. We put these parentheses and we do array list of accountant, right? And now it's compiling, it's not erroring out. And we were able to change the data type for this variable to accountant. And because of that, we can access the methods that are visible in the accountant type. So it's emp.work. And there you go, that's it. Now let's hit play and notice that it's working as expected. And of course, there's going to be warnings. Whenever there's casting going on, it's going to give us a warning. Hover your mouse saying type safety, unchecked cast from blah, blah, blah to array list accountant. All right. It's warning us that this is an unchecked exception, meaning the compiler cannot ensure type safety here. All the compiler can ensure is that whatever data is passed in as an argument is a list of employees or their children. That's it. It can't get into the specifics of which child. So for example, if I create another class, and we'll call it HR manager, and we'll say that this extends employee, all right? I could, if I wanted, I could change this to HR manager and change the data type for this to be HR manager, okay? Now, HR manager doesn't have the work method, but you can see that it's not smart enough to know that the data that's in employees that we're passing in here is actually accountants, but we are downcasting to an HR manager, all right? And that's why it's giving us this warning and saying that, hey, don't depend on the compiler to help you here, because the method definition accepts anything that is a child of employee. And since HR manager, right here, this class, is a child of employee, whether you pass it as an argument or not, the Java compiler is not smart enough to figure that one out, okay? I would encourage you to not do typecasting if possible, okay? Try to minimize the usage of this sort of thing, because this leaves room for a lot of error in your code. Someone could change something above or in another class and you wouldn't know it, or they wouldn't know it, and type safety may be jeopardized in one way or another. So whenever you're typecasting like this, downcasting or upcasting, you're ignoring the type safety that Java offers. Now, there are certain problems where you just have to do this sort of thing, where you have to do typecasting, but don't take it for granted and use it everywhere, okay? All right, so we've covered a lot of ground in this video as well as the last one, and hopefully this gave you a good understanding of generics. This is a very important topic in Java. Once you understand it thoroughly, your fear of reading Java code will definitely be eliminated. Because if you understand generics, then that means you understand object orientation and you understand how programs are structured. And it'll be easier for you to read other people's code the more syntax that you understand. Now, Java has a very elaborate syntax as you've been seeing in the course, but we've really laid a good foundation for understanding majority of the things. If there's something that you're not clear about and you need to Google it, that's totally fine. But you have a significant amount of knowledge up to this point to tackle any Java problem that comes your way. It just really requires a lot of practice. So in the next lesson, I'm going to be giving you a generics assignment, a project that will really hone your skills and give you more confidence with generics. All right, so let's wrap it up here. Thanks for watching. I'll see you in the next lesson.